Okay, moving on to the third last, no, the fourth last chapter in your textbook. So we're just three away from completing the syllabus for this year, and then you're on your way. Uh, Today we discuss one of the very few important topics uh, uh, for this year, which is organic reaction and synthesis. It's a fun topic because you'd be asked to synthesize organic molecules, and you'd be given a starting material, and you'd be asked how would you synthesize the final organic compound. It's really fun. It's If you're good at maths, this might be really easy for you, because it's just one step to the other, to the other, to the other, A to B, B to C. It's logical reasoning mostly. uh, but we're going to start off with some concepts that we are already familiar with, and the first one is the definition of oxidation and the definition of oxidation. The two definition of oxidation we know. One is in terms of electrons, and the other is in terms of loss or gain of hydrogen or oxygen. So what I want you to do is spend a couple of minutes, or not a couple, probably a minute, talking to your friends, talking to your partners about the two definitions, and then I'll get you to tell me those. So just go ahead, talk to your partners the two definitions of oxidation that you already know. Thanks. So the answers that I got from the students is that in terms of electrons, the loss of electrons is oxidation, and in terms of loss or gain of oxygen or hydrogen, the gain of oxygen is oxidation, and in the same process, the loss of hydrogen, if the molecule is losing hydrogen, that is also oxidation. Uh, Now we're going to talk about oxidation reaction examples. From your knowledge, in groups of four, come up with oxidation reactions for organic compounds. You may consult the textbook, but you cannot exactly use what's given in the textbook. Uh, you can't use the exact same reaction. You're free to use the textbook anyways, but don't use the exact same reaction. So I'll give you another 2 or 3 minutes to discuss this in your groups and come up with an answer, and then we'll move on. Thanks. So from the think, pair, and share, I got three different reactions. The first reaction was the combustion of ethane, which would be C2H6 plus oxygen would give you carbon dioxide and water and H2O. Another reaction that I got was ethanol plus, sorry, it should not be, ethanol plus oxygen would give you carbon dioxide plus water. Now, there was another reaction that was mentioned, uh, which talked about an alcohol converting to an aldehyde, alcohol to an aldehyde, which was mentioned as an oxidation reaction. That's pretty interesting, because up till now we have just learned that when we expose an organic compound to oxygen and we heat it, we turn it to carbon dioxide and water. And this one's interesting. So we will get to a discussion about how that happens. But right now our focus is just complete combustion of organic compounds. So with that information in your head, could you please practice question 1 and question 2? I'll give you 5 minutes to do that from set 17. Thank you. Okay, now once you've answered question 1 and 2 from set 17, I wanted to move on to synthesis by oxidation of alcohols. So what do we get when we oxidize alcohols? And we've already been given a hint from Big T that we get aldehydes, and that is true. We will talk about that later, but right now in your groups again, just take a minute to give me two uses of combustion reactions for alcohols. What are the two uses that you can think of? Okay, the two uses of combustion are: combustion will provide you energy, which you could use to run your cars, energy to run cars, for example. And if you're thinking about a concrete example of this, um, you can think about the E10, E15 fuels that you put in your E10 or E15 biofuels that you put in your car. The second one is nothing. You don't have any other use of combustion, of oxidation in the conventional sense. Like if you consider complete oxidation, or if you think of oxidation in the conventional sense, you don't have a second use uh, of combustion reaction. So, but there is a second use for oxidation of alcohols, and that second use, if you talked about the second use in terms of oxidation of alcohol, is the production of acids, carboxylic acids for that matter, of carboxylic acids, ketones, or aldehydes, which by themselves are a class of organic compounds, classes of organic compounds which are very useful. So if you could just quickly note this down, I'll move on to the next part. 30 seconds. So we did mention just previously that oxidation of alcohols can also give you uh, ketones or aldehydes or carboxylic acid. But how do we accomplish that oxidation? The only way we know how to oxidize is, up till now, the way that we know is just burn it. Just burn the thing, combustion. That's what we know. But there's another process, and that happens in a controlled laboratory environment, and we call it controlled oxidation. And that happens in the presence of acidified KMnO4, potassium permanganate, or acidified K2Cr2O7, potassium dichromate. So anytime you have to carry out a partial combustion, you would use these reagents. These are called reagents. A very commonly used term in chemistry, reagents. You would need to use these reagents. Now, just as an example, let's say we started off with a 1 degree alcohol, and let let make let that 1 degree alcohol be CHH. Now, this is an alkyl group. It could be anything. It could be the methyl group, propyl group, ethyl group, whatever. It could be anything that you want it to be. And this is OH. Now you are starting with a 1 degree alcohol. Why is it a 1 degree alcohol? Because to the carbon to which OH is attached is only attached to one more carbon. So it's a 1 degree alcohol. You accomplish incomplete partial oxidation in limited Cr2O7 to negative H positive. Now, if you do that, how did we describe oxidation? Anyone? The loss of hydrogen. So what we're going to do is we're going to lose the hydrogen. So let's lose this hydrogen, and let's lose another hydrogen. Let's lose this hydrogen. And if you lose the hydrogen molecule, you end up with RC.
What's R again?
It's an alkyl group.
Okay.
Thank you for asking. Alkyl group. C double bond O and H. Now this, as we know, is called an aldehyde. But what happens if you accomplish a complete combustion? So first you'll get an aldehyde, and then because you're adding, this is excess. So I know it looks like Arabic, but I mean this is EXCESS, excess. So if you add enough Cr2O7 to carry out complete combustion, you'll add up an oxygen molecule onto this compound, onto this aldehyde, and you'll end up getting RC double bond O and now you're adding what to it? You're adding you're adding OH, and that gives you a carboxylic acid. So basically, what you've done is added uh, an oxygen molecule to the hydrogen here, and you get a carboxylic acid. Now, what would the exam questions look like? A question would be like, you have your starting alcohol is, let's say, propanol, and you'd be asked to uh, form propanoic acid. How are you going to do that? So you would have to show the steps through it. And this is a very simple case. The questions would be more complicated. Anyways, so if you could quickly take this down, or if you have already taken this down, I'll move on. What happens when you have a 2-degree alcohol? So this is something that you can work out in your team. I'll give you a couple of minutes. What happens when you have a 2-degree alcohol, and what happens when you have a 3-degree alcohol? I'm asking for what happens if you have a complete combustion happening. So if you could just give me the names of C and D. You could choose whatever 2-degree alcohol you want to and whatever 3-degree alcohol you want to, and we'll discuss that in 3 minutes. Okay, so the answer to C was a ketone, and the answer to D was nothing. So you would get nothing if you oxidize a 3-degree alcohol. So once you've attempted question 3 from set 17, you should be moving on to writing balanced half equations for oxidation of alcohols, like we just did right now. So you did the molecular equations or the chemical equations, in which you had a reactant and you converted it into a product. But how do you write half equations? Well, it's no different than how you wrote half equations for redox reactions. So it's the same thing. What I want you to do is go back, look at your rules for oxidation in the presence of H positive. Now, the oxidation occurs in the presence of acidified KMnO4. That means it is an acidic environment, and acidified K2Cr2O7, acidic environment again. So try doing the partial oxidation and complete oxidation reactions. So partial oxidation of ethanol and complete oxidation of ethanal. So an aldehyde, and this is an alcohol. Try doing that. I'll give you the rest of the time to do that now. If you don't get it done, you might want to do this at home, and you do have homework, which is this whole of set 17. I will give you, look, I know it's a big set, so what we'll do is, and we are way ahead of where we need to be. So if you can get 3 questions done, 4, 5, 6, and 7, we do 8 and 9 in class. Okay, we do 8 and 9 in class tomorrow, but you still need to get questions till 7 done. With that, I think we're done with the class. Thanks.